So today we are going to discuss about the basic refrigeration cycle or air conditioning, that is Rankine cycle. Okay. So the basic components behind these cycles are: first one is evaporator, next one is condenser, then compressor, then expansion boiler. So these four components are major components for the Rankine cycle. Okay. So the first one will be called as evaporator. So you are all are using air conditioning, right? Okay. So in air conditioning there are two units are there. Virtually there are two units. One is indoor unit, another one is outdoor unit. You all see that, am I right? So the one with the fan, okay, which plays the outside, that is compressor. Okay, compressor and condenser will be in the outside, and evaporator will be in the inside. That is, in the indoor unit, it will be called as a evaporator. In technical term, it will be called as a evaporator. So, where the air conditioning systems are deployed in automobiles, in households, in commercial buildings. Am I right? So there are a lot of air conditioning applications are there. So similarly, refrigeration will also be the same. The principles are the same. The applications are the different. Okay, the principle remains the same. Both evaporator, condenser, compressor will also be there. All the mechanisms are same. Only the difference is air conditioning and refrigeration. The only difference is you can alter the temperature in air conditioning system, but in refrigeration you can't set the temperature. In fridge you can't set the temperature. That is like the air conditioning system, that you can set the temperature to 21, you can set the temperature to 16, you can set the temperature to 30. Whereas those functionalities will not be present in the refrigeration system. Only the high, medium and low temperatures are present in the refrigeration. But now, due to the technology advancements, these also can be implemented in the refrigeration also. You can set the temperature to 3 degrees centigrade, you can set the temperature to 30 degrees centigrade in the fridge itself. Okay. So the first one is, let's say, go to the indoor unit. Okay. I will talk to the indoor unit. Okay. So in indoor unit, if you open the box, you will be seeing the copper coil surrounded by it. Have you come across the copper coils? Okay. Inside the copper coil, you will have a refrigerant. Okay. Refrigerant. It is a liquid. It is both present in the gas as well as the liquid. Okay. It is called as a phase change material. Okay. With the low temperature or with the high temperature, the phase will be changed to liquid to gas to liquid. It can alter the phases very easily. That is called as a phase change material. So refrigerant is also one of it, and those refrigerant will be present inside the copper coil. Okay, when you switch on the AC, what will happen? Blow air inside the indoor unit will suck the air from the room. Okay, so for example, this is the copper coil. Consider this is a copper coil. Then inside the copper coil, you will be having a refrigerant. Okay, once inside the room, the blow air starts sucking the air, right? It will pass above these copper coils. So inside the copper coil, the refrigerant will be low in temperature, whereas when compared to outside, the temperature is very high. What will happen? Outside the air temperature is very high. Inside the refrigerant, the temperature is very low. What will happen? The heat will be exchanged from outside to inside. So the outside air, the temperature will become reduced. Okay, because of the heat exchanger. So the temperature of this outside air will be reduced, and again it blown to the inside of the room. Okay, then this refrigerant, it absorbs the heat, right? So once it is in a liquid phase, it will eventually turn into vapor stage, gaseous stage. Okay, so because it absorbs the heat, the phase has been changed. Okay, then this, what do you call it? This phase changed refrigerant will go to the next section. Okay. That is condenser. Okay. In condenser, here it is a phase changed, right? Sorry, next it will go to the compressor, that is outside unit. The outside unit will go to the compressor part where it gets compressed. So this heated gaseous form of refrigerant will be superheated due to the compression effect. Okay, the pressure will also be increased. Then it becomes a superheated state. Okay, then it goes to the condenser part. What is a condenser? What is generally a condenser? Condense means. So with the help of, I will tell you. So condenser means, so with the help of some external sources, I can change the gaseous form to liquid. Okay, evaporation means liquid to gases, right? So where inside the indoor unit, evaporation will take place. Okay, liquid to gas, evaporation will take place. Whereas in condenser, what will happen? Condensation will take place. Condensation means vapor to liquid. Okay. So that superheated stream of refrigerant will go to the condenser with the help of atmospheric air. Okay, the heat will be exchanged to the atmosphere. Then automatically that steam or that liquid, gaseous form of refrigerant will then turn into condensed form. Okay, refrigerant then moves to the as a liquid form. Then automatically after condenser, it will goes to the expansion hall, and after that it moves to the again indoor unit that is called as an evaporator. It is a cyclic process. Okay. So the inside room temperature will be absorbed with the help of refrigerant. Then the refrigerant will lose the heat to the atmospheric air by means of evaporation and condensation. This kind of a phenomenon. Okay. This way the air conditioning will work. But if you see a fridge, as you can see that, okay, it is a practical example. You can see that here the only difference is evaporator is placed here. Okay, the evaporator is called as a freezer. It is placed. Okay, all the above things are placed outside. Am I right? Similarly with the air conditioning. But why have you ever imagined why the freezer box is kept always the above? Have you ever wondered why the freezer box is kept always above the top of the fridge?
Sir, air circulated from upper to down.
Okay, air circulated from upper to down. Yes, that is good. Any examples? It is a simple, right? It is a freezer. It has a cold air. So cold air absorbs heat from the place. It's the similar kind of phenomenon, but it is a kind of natural convection, as you see. So if you understand the natural convection, then fridge is the example. So here, inside the freezer box, it is a ice packed one. So the air becomes cold. So the cold air's density will be very high. Automatically, cold air's density is very high means what? Automatically it flows to the downside. Okay. Here at the bottom of the thing, you have a hot air. For example, if I place an apple inside it, okay, what will happen? The apple's temperature will be absorbed by the surrounding air. So the air becomes very hot. So hot air generally tends to move upward, whereas cold air tends to move downwards. So it is a natural convection, natural circulation. Okay. So once you place the freezer box above, then cold air will come down. It moves the hot air to the upwards. So it is a natural circulation. Whereas if you place it, you imagine, if you place the freezer to the bottom, what will happen? Hot air becomes stable at the top and cold air at the bottom. There is no natural circulation will be there. So that is why the freezer box is always kept above the freezer. Above the top of the freezer. Okay. Then the same AC and fridge both are working same right now. Okay, I open the fridge. Okay, whether inside the room temperature, you feel whether inside the room temperature will be cooler?
No, sir.
No? What? I kept the fridge open and I sit in the room. Do you feel ever that my room will be cold? Why? It will be cool, sir, but it will take more time. It will take more time. How much? Any Answers? These suggestions? So here all the parts, all the components, that is evaporator, compressor, okay, condenser, all these components are placed in the room itself. So once you open the fridge, again you feel the cooling effect. But since you open the fridge, then the load will be increased. Then the load of the compressor will also get increased. If compressor is running, it will generate more heat. Okay, then you can't feel that cooling effect. So that is why in AC, evaporator, that is cooling part is kept inside, and all the components are placed in the outside itself. That is the reason. Once you open, if you open the fridge also, you can't feel the cooling effect inside the room. That is the reason. Any doubts? Thank you.